centrifugal plate in the de-oiler, and the air, because it has large quantity, it will be breathed out through this one here, through that screw. You can see it, there is a drain mass on the aft, and the air can go out.
Sometimes you see this white smoke.
White smoke, always it comes with the white smoke, because it's coming from the hottest area of the engine. All right?
Yes, sir.
So clear? Let's go to the other side of the core of the engine. Come in here so we can see. Here nothing much, we can see the BSBV actuator here. And we said that there is a slave actuator on the other side where we saw it at 3 o'clock position. You see the slave valve. Come in. So bring them in. So this is the BSBV actuator. It's a ball screw type actuator connected to the ring. There is a ring that moves forward aft to block the low pressure air from the high pressure compressor and to prevent from bleed out. Not like the CFM engine. The CFM engine has those valves, they 12 valves, they open, they close to relieve the excess of air in the low pressure compressor. Here we have plug ring. The plug ring is driven by this actuator and the slave actuator on the other side. That means 2 actuators, we call them ram air actuators. They open the ring backwards and they bring it backwards and forward. So they block and they open that to bleed the air. When they plug, they close, all the air from the low pressure compressor goes to the high pressure compressor. When I open the ring, then some of the air will be leaking outside into the core of the engine. All right? This is the VSV actuator, the variable stator vane actuator, this one. It's a heavy duty actuator, this one. That's the one which is connected to this yoke, we call quadrant, and it drives the 1, 2, 4 stages. It drives 4 stages of VSV blades, plus the IGV, the inlet. So we have a VIGV stage plus 4 stages. That means we have 5 controlled rotating stators inside this engine, because it has 10 stages, not 9 stages. On the CFM engine we have 4 stages. Here we have 5 stages that we can control them through the VSV actuator. The IGV plus the 4 stages. And they are driven by this yoke here. All right? This is my high pressure valve. This is the high pressure valve location. And remember, high pressure valve location on the 10 stage, right? 10 stage, location on the 10 stage. And that is the 7 stage valve. Here you do the deactivation. You look, you put this in this center. Now it's in the closed position. And you remove this pen and you put it there. Screw it in there so you can lock it mechanically. So the same as the CFM engine.
So where is the PRV?
Right.
On the top, huh?
Put your hand on it, Ya Abdullah.
Okay.
That's the PRV. It's identical to this valve. Alright? The same thing, we can deactivate the PRV when you look at the PRV here. That's, you can see it direct. You put this in the closed position, you remove the pen here, that's the pen, you see it? This is the pen. Remove that, put it in here, screw it in, then this valve is deactivated in the closed position. That's the activation. Okay? The same thing for the valve here. This one is near. You can see that here, put it in the closed position, remove the pen, put it in here, screw it, and then it locks with this slot. So it does not move anymore. So we lock the valve mechanically. All right? VSB actuator,
IP.
BSB. This is the IP. This valve. It's an IP check valve. The upper one is overpressure valve.
Okay.
The overpressure valve is there. This is the fan air valve.
Okay.
Same as the CFM engine with the bleed system. There is no difference. Recoup valve for bearing number 4. And this sensor here. See the sensor?
Yes, sir.
This one here. This is the nozzle temperature sensor. CFM nozzle temperature, we saw it at 12 o'clock position, front of the upper bearing. And here we have this one at 6 o'clock position. This one here, NAC, nozzle temperature sensor. Signal, this indication will be indicated after engine start. During engine start, you will have engine starter valve indication. But once the engine is started, the starter valve closed, the starter valve indication disappears, then we have nozzle temperature indicated instead. All right? This piece here is made of platinum. So this sensor is very expensive, gentlemen. This sensor is about 60,000 US dollars. It's made of platinum. Inside this sensor here, there is a platinum. All right? It's very expensive sensor. To measure the temperature. That if there is any rupture in the ducts of the oil leak ducts in here, it will be sensed as the engine shut down.